Hello and welcome to Season 4, Episode 43 of Logicast, the AWS News Podcast brought to you by Logicata. I'm Carl Robinson, CEO and co-founder of Logicata, and I'm joined today, as always, by my colleague, lead cloud engineer, but perhaps not for much longer. Ooh, air of mystery around that introduction this week, John Goodall. How are you doing today?
Oh, I'm knackered. I'm dead. For anyone that is watching the video stream, this is an energy drink, not beer. But I've been in a 5-hour audit call, 4.5 hours. So it's absolutely necessary right now.
Me too, but I managed to grab a couple of coffees during the audit, so I've come out the other end feeling wide awake. So, yeah. And in case anybody was wondering about the introduction, John's not leaving, but his job title may well be changing for future episodes. So watch this space. We're also very lucky to be joined today by Loic Fournier, a Senior Technical Account Manager at AWS. How are you doing today, Loic?
I'm fine. Thank you so much. Glad to be here with you.
Tell us a little bit about what you do in your role as a Senior Technical Account Manager at AWS, then, Loic.
So, as a technical account manager, our role is to help the customer to get the best of the cloud on AWS, advocate for them internally, help them to connect with the service team for feature requests, help them to, operate in a secure way, resilient, and with operational excellence, and also optimize their spend around their workload.
Cool. Any particular sector that you do that in?
Yeah, I'm in public sector, so I'm working mainly now with the international organization.
Cool. Sounds exciting. I guess there's some pretty big AWS bills involved in those size of organizations.
Yeah, quite big, and yeah, this is my role to be sure that they are big but optimized.
Absolutely. So cool. Well, as regular listeners to the podcast will know, once a week I curate a list of AWS news via my weekly AWS News Roundup newsletter. And then John selects a subset of those articles that we share with our guest for discussion. But actually, this week, we're not going to do that. We're going to do something slightly different. We did actually discuss one of Loic's blog posts on a previous episode of the podcast. And that was a blog post all about how to optimize Amazon RDS and Amazon Aurora database costs and performance with AWS Compute Optimizer. And we made a few comments about it on the previous episode, which Loic picked up on social media. And he wanted to come along today and set us straight, I think, on a number of those comments, but also perhaps take a little bit of a deeper dive into things like Compute Optimizer, cost optimization, etc. So we thought we'd center our discussion around a couple of posts that Loic has written recently. The first one is the one that I mentioned about optimizing Amazon RDS and Amazon Aurora database costs with Compute Optimizer. And then we're also going to talk a little bit about introducing AWS pricing capabilities in Amazon Q Developer. But let's start with the Amazon RDS and Amazon Aurora database costs and performance with Compute Optimizer. Let's start with the point that we picked up on before, because we discussed it in our preamble, that this seems to be about optimizing costs on databases, but the title of the article includes Compute Optimizer. So databases is a separate category of services in RDS from compute. So what's going on there then, Loic? Why is Compute Optimizer now doing database stuff?
In fact, you know that I would say the majority of the features that we are developing are coming from the request of the customer. So we are working backward from the customer, and I would say this is the main area following the previous feature that were released on Compute Optimizer, that we hear from the customer that they need help to optimize. And I would say before June 2024, when this has been released, when I have to optimize the database with my customer, we can spend entire days to, I would say, collect the metrics from CloudWatch, or I would say performance, the different performance from the different tools, and it was super long to collect, analyze, and extract valid data to define what would be the right size, the right instance, and the right configuration. So indeed, having this kind of tool that in, I would say, average 30 hours of metric collection using machine learning and benchmark behind the scene, is able to provide the best recommendations for free, except if you go into enhanced infrastructure metrics. I would say it's a great asset for the customer.
Cool. So the prior to this Compute Optimizer feature being launched, did you need to kind of pull all of this together manually, the statistics to
Yeah,
provide the
absolutely.
recommendations?
I would say of course, there are some tools that depending, some customer have third party tools, or depending the database, you have I would say some way to collect the metrics quite fast. But then the decision in order to decide which instance along the 100 instance type that we have will be the best fit according to the metrics you have collected, could be quite long. And I would say, in terms of safety net, you would have to spend time to test. Here, because of the way that Compute Optimizer will provide the recommendation based on different, I would say, there is not only the metric that we are collecting from the database, we are also doing benchmark on the instance. We are also collecting metrics from the storage, and all of these together, plus the comparison, the machine learning process being the scene with the benchmark, give you the ability to automatically get directly the best instance, either on Intel or Intel, I would say x86 architecture, or on Graviton. So it will directly recommend either one option. But one of the best, I would say, recommendation that I can give for the customer using Compute Optimizer for their RDS or Aurora recommendation is, of course, to go for Graviton, because if you are using Postgres or MySQL on AWS, it's a managed service. So all the underlying architecture is managed by AWS. So there is no risk to go for Graviton, but you will, I would say, the only benefits will be to get better cost performance and sustainability. So as soon you are using managed service on AWS, the best recommendation is to go for Graviton. Now, between all the Graviton, getting the right sizing provided by Compute Optimizer up to your usage is also another asset.
So you mentioned that occasionally there are recommendations for Intel-based instances. Your recommendation, obviously, is to go for Graviton, and that's typically what we're seeing with our customers as well. For those types of instances, that we are pushing them down the Graviton route. When might the tools recommend Intel-based instances over Graviton?
So, in fact, you because there are, of course, for the database, there are some, I would say, for Postgres and Aurora, Postgres on Aurora and RDS, sorry, or MySQL. I would say it should not be, it should not even have a brainstorming. It should be automatic to go for Graviton. But there are still, I would say, customers that I would say have not tried, or are still hesitating, or because they start a long time ago before, and depending the region also, maybe there is sometime in some region you could not have the right Graviton instance and you need more power, and so there is different reason. But essentially is for EC2 instance, this is where you can need to get to stay on x86, because of course there are some application, Windows application for instance, there are some application that will not work or need some effort to migrate on Graviton, to work on Graviton. This is why Compute Optimizer remain with an option to I would say to suggest recommendation on both architecture.
So we as I said, regularly make these recommendations for for moving MySQL and Postgres RDS instances to Graviton if the customer's not already there. I'm curious if you've ever seen any problems with that, because we always reassure customers that yes, it's a managed service, it's completely seamless to you, and we've never seen any problems. I'm just curious if you've ever seen any edge cases where that's been problematic.
No, never edge case. And no, this is totally transparent, because the I would say the underlying infrastructure is managed by us. So for the customer, this is absolutely transparent. And of course, we always recommend the customer to go to the normal life cycle, meaning dev, test, prod. We will never tell to the customer to change the architecture and to go directly to prod, because it's very important to follow the process. But indeed, I have never seen any issue on Postgres and MySQL related to usage of Graviton.
Good.
And
Well,
and also I never had customers. Sorry to interrupt. I've never had customers saying, after having gone through a migration to Graviton for their database, that the performance were below what they got before.
It's interesting that you call out MySQL and Postgres specifically, and the article does that as well for the Compute Optimizer function. Have you ever seen problems with doing it for other database engines? Because I know SQL Server is probably quite iffy, being
No,
Microsoft.
because Graviton, I would say Graviton. If you are using Oracle and SQL Server, you cannot go to Graviton. This is why.
So he's never seen a problem because you just can't do it. So,
Yes, you can do it. Yeah, that's why.
so I'm just going to touch on that a little bit more then, because the first article that we're kind of basing this on talks about RDS and Aurora, Postgres, and MySQL, but it doesn't have any recommendations for other database engines. Is there a reason for that? Is that because it's hard to get the metrics out, or what was driving those two being the first ones?
I mean, the idea. So I'm not the product manager, but indeed. So the way that we have managed service RDS for Oracle and SQL Server, but we are not handling the performance and the collection of metrics in the same way. I know that there is feature request, and I mean, I think it's more related to the request from the customer. So this is a good question that I can ask to Rick about the reason why. But I think this is because first, we are very often encouraged in cost optimization to migrate the customer to the non-licensing or to open source database for the cost of the licensing. So as this is the goal is to perform optimization for the customer, we are encouraging the customer to migrate when this is possible. But I think it's more because it was mainly requested on those products than the other. Um, but I can next time I will follow up, and I will ask Rick about this the product manager to know why. If there is a specific reason.
Yeah, I've never seen a SQL Server that was properly optimized because it's just not.
I have not an accurate answer, so I just guessed that it's because we are working backwards from the customer. But I will ask the question next time, and I will follow up.
No, it's interesting. Just going to kind of scoot through a couple of bits in the article just generally, because I did pick a few bits out last time, and whilst my memory is not amazing for that long ago, there was a couple of interesting pieces. So the first kind of bit is there's a few different categories, aren't there, of how it's doing the database optimization, and it sort of spits the resources back out as optimized, not optimized, or idle, which is okay. That sort of makes sense. Idle, it's not doing anything. Not optimized is you've kind of over provisioned or under provisioned or whatever. The idle database one I thought was quite interesting because, according to the article, as it says, It's not being used as a read replica. There's no connections over the particular look back period. For RDS and Aurora, it's pretty similar, but it's not part of a cluster, low CPU, kind of all the rest of it. How did those particular metrics come about as being that probably means it's idle? I mean, no connections is pretty obvious, but there's a few others in there that you think, okay, how have you come to that as a thing?
Yeah, so first of all, I think this is important to mention that Compute Optimizer focus is not first and foremost targeting the cost optimization. The main objective of Compute Optimizer is the performance. So the idea is not to tell you first if you can save money. That is the cherry on the cake. The goal is to tell you if your workload, so compute or database, is optimized for the application or the process, the batches that you are running on it. So this is why you can be, as you say, under provision or over provision, and or idling. And why you have such, so there are different rules. I told you there is machine learning, so we are collecting metrics, and on top of this we can consider that there is a rule that we are checking, because if you have a cluster, of course you are doing active passive, you will have a machine that is not active. But if we are telling to the customer that, yeah, your your backup of your cluster is not active, they will say, yes, I know that. It's obvious because this is a backup. So this is why there we need to, if we want to be trusted by the customer, and the customer, I would say, use Compute Optimizer, there is a large adoption of Compute Optimizer. It's super important to first give accurate recommendation with the accurate safety nets, to ensure that if the customer is moving to the target recommendation that we provide, they will not have to, I would say, roll back. They will get the performance expected for their application. And you can see, and I find this very, I would say, absolutely great, that you have the projection and the forecast on the graph. You can see if you are picking option A or B, what will be the consumption of the memory and the CPU. And also, it's important that we are, I would say, taking care of eliminating the main, I would say, use case, that where the customer can tell us your recommendation is silly, or is not good, because yeah, my utilization is for backup, or it's a cluster, whatever. So yeah, and in terms of idling, so we are inspecting if there is, so what we will check is with Performance Insight, if you have activated the tiering of Performance Insight, we will get additional KPIs like the DB load. And as soon you have the DB load, you know exactly how many connections you have to the database. And so the CPU can be one thing, but if you have the number of connection, the DB with the DB load, there is no connection, so you know exactly that the database is idling. So when the database is idling, you have two options. You can stop it for 7 days, and then you can do a snapshot and restore it when you need it. Or even you can think about, if you have period of idling like this, because your database is used time to time, to move to Aurora with the option scale to 0, Aurora serverless, and I would say get your database when you need it, and pay only for what you need. And just to tell you, you need only 15 seconds, 15, 1 5, to scale up from 0 when you need, when a connection is coming.
I did see that, and I'm a big fan of serverless generally. That's kind of my bag, and serverless databases are quite cool. I was railing against Aurora Serverless V2 back when it wasn't actually scaled to 0. Absolutely railing against it. You've called it serverless, it doesn't scale to 0. It's not. You still have to pay for it to exist. You can't call something serverless if you pay for its existence. And that gateway is not serverless. You pay for it to exist. It's just, that's the line. But yeah, that one's quite interesting. I didn't realize it was 15 seconds.
Yes.
That puts it at a very interesting sort of point, because 15 seconds to bring a database up from cold is actually really, really fast. But it's not fast enough for production workloads quite a lot of the time, I find. So it's one of those, we've done this a few times with customers as well, where we've gone, well, we love serverless, we love Aurora, we love kind of not having to think about these sorts of things. We cannot in good conscience recommend that you use it in production in serverless mode, because it does just take too long. 15 seconds is not long, but it does take too long to come up. So your first handful of requests are just going to go and fall over. Outside of that, it's great.
I mean, it's really dependent of the use case. I think it's not about production or non-production. I think it's really working backward on the use case. And indeed, for some use case, it can work. For some, not, because the front end, if the front end can handle this time, I would say, this waiting time, that could be indeed working. But yeah, I think it must be analyzed use case by use case.
Yeah,
Stick a very complicated capture in front of it. click all the squares with stairs in them. Oh, that's going to take 15 seconds while the database comes online.
Oh dear. I suppose that's the point, isn't it? Is I say the word production, and I think of a lot of our customer base, which are B2C, lots of e-commerce going on, and for that sort of thing, production e-commerce, you can't afford that sort of wait line. If it's an internal application, if it's a reporting tool, if it's something that's only used in business hours, if it's B2B, even to a great extent, then a 15-second wait and sorry, we're still spinning up, come back in about 30 seconds is probably fine. Speaking of outages, we appear to be continuing to have some. Back again.
Restream has just chosen to rearrange us all. There we go. So, John,
I'm puzzled
this time.
Yeah, John, you've alluded to the.
Are you going to turn your camera off, and then is it just going to be a picture of me instead?
Maybe that's what happened the other week. But you have alluded to the Cloudflare outage in your little speech bubble there. So I do think we are being affected right now by a Cloudflare outage, because I was unable to log in, and now we're suffering from some instability. But there we go.
Yeah, at some point also, if you need for B2C e-commerce, for instance, and you are using serverless, will not be a good fit if you need 24 hours running a database. Serverless will be more costly than provision one. So there is also that to consider. Serverless is when you have a managed service on serverless, it's very efficient if you have period of interruption during the day in terms of peak of activity, interruption of activity. If you have a continuous activity, serverless will not be, I would say, the best option in terms of cost.
Yes, if you've
there's a line there, isn't there? Because some e-commerce doesn't necessarily mean global. We say e-commerce and we think, Amazon.com. That's global. That's being used just constantly. Versus e-commerce being, for lack of a better example, Etsy UK specifically. No one is going on that at 2:00 in the morning, or like one person is going on it at 2:00 in the morning to get custom designed, laser etched name tags or whatever, random stuff that you find in these sorts of websites. But it's still one of those. I don't know if you can scale it to a sort of a level. Maybe what you could do is set the minimum at something like a half capacity unit, and then once it's not truly serverless,
you can.
Paying for it, and it goes right the way down.
I would say you can configure the scale to 0, meaning that if you have a permanent activity, it will just scale in and scale out according to what you need. And the scale to 0 will happen only if you have actually no activity for a period of idling. That's as you mentioned. But indeed, I mean, for e-commerce, this is quite not an option that should, I would say, be used.
I guess if you've got an e-commerce website and your production database is being classed as idle by Compute Optimizer, then you've got different problems, right? It's
absolutely. Yeah, I was about to say the same.
Yeah, lack of customers is your primary problem there.
Bigger problem there.
How
we need to
quickly
optimize for costs because we're not selling anything.
So I was just curious, Loic, about we sort of mentioned that Compute Optimizer is not all about cost optimization. You may or may not be able to answer this question, but just at a very high level, in terms of the recommendations that you see coming out of Compute Optimizer, do you see more under-spec'd databases or over-spec'd databases? Is Compute Optimizer, I don't know if you have like high-level stats, just at a kind of an AWS level, is it finding more opportunities to upgrade or downgrade, or is there kind of like a ratio or a percentage of those?
To be honest, I have not the official statistic from AWS, and that only the service team might have this. But I have a quite a lot of customer, and I'm part of what we call internally in AWS technical field community of cloud financial management. So I'm helping also not only my customer, but I have time dedicated to help customer. I would say implementing FinOps governance or helping them to set a good FinOps posture. And I would say 80% of the time there is this is over provision. So the customer are usually doing a migration, and because they are starting their cloud journey, they want to be sure that everything will be okay. And this is the big difference with the on-premise mental model, where you were sitting with I would say with everyone, and you were discussing a project, ordering a machine that will stay here for 3 years, 4 years. You have to be sure that you will get something powerful enough to cover 3, 4, 5 years of growth. Here in the cloud, sometimes when the customer are starting their cloud journey, they are doing the same, they are repeating the same mental model, and they will, I would say, over provision the machine. So there is two cases mainly: following the migrations, or the customer that has so maybe three cases. So also the technical team, which is completely decorrelated from the business and want to be sure that he doesn't know too much about the business case, and he want to be sure that all the peaks will be covered. So we are all over provisioning. Sometimes you have also the database that is not well optimized in terms of the caching or I would say if you are or there is no more maintenance, but sometimes it's just the configuration of the database, or you have a missing index, and so there are some queries that will be long, so they will increase the machine to compensate the problem of storage. For instance, I have seen customer increasing the instance type because they have their storage were configured with GP2 storage. And you know how GP2 is working. You need to have extra size to get better performance. When for GP3, so on RDS, GP2 and GP3 are at exactly the same price. It's not like EC2 where you have 20% of discount for GP3. So GP2, GP3, this is exactly the same price for RDS, but you are getting the better performance for GP3 from 50, the minimum size, which is 50 gigabyte, when you need nearly 400 gigabyte to get the same performance with GP2. So sometimes they are not looking into the real reason why the database, some query are long. Could be missing cluster, missing index. It could be because the storage is too long. They're increasing the size of their machine. So to make a long story short, 80% of over provision. And also there are some case, the last case is where the third party, so marketplace, they order a machine on this marketplace, and the third party will tell, they want to be sure that everything will work, so they are giving twice or third time the capacity that is really required.
Do you ever see any recommendations, just to touch on the storage side of things? Because we talk about just EC2 storage in generally as well. GP2 to GP3 being a big one. We've seen a couple of times where people have gone, particularly in kind of older databases, where they've gone IO2 because they wanted to be able to configure IOPS. And then the level that they've configured them at have been so small anyway. I'm like, why did you bother? That would have been included in your GP2 baseline. So why did you do that? And the question really is, I don't know if there's recommendations now, but is that something looking at moving from these higher price, older style like IO2 storage types to GP3, where the base cost is lower, you can still configure the IOPS and just save a bunch of money that way?
In fact, the full story is by the book, and I would say I sometimes I'm not here to disagree or agree, but the book we recommend to GP2 and GP3 are recommended to for test and dev, and IO1, IO2 are the what we recommend for production. Why? Especially for the latency and the way the architecture of the storage, which is different between direct attachment and network attachment. So um, I would say by the book, I will always recommend IO1, IO2 for production, GP2, GP3 for dev and test. Now it's important also to consider between a database with 3 connection and 3,000 connections.
Yeah.
So if you don't if you it's and this is where Compute Optimizer will be also able to show you and to tell you, okay, your storage is over provision. Look, the IO read, IO write, you don't need that much, and you can decrease your storage. Of course, on Aura, you do not manage the storage, so the storage is automatically managed. That's one of the benefits of Aura. You do not have to ask you if I should choose IO1, IO2, GP2, GP3. It's simple. You have resilient storage, and everything is managed by us. But yeah, for RDS, I think Compute Optimizer, at least for Postgres and MySQL, will be a great asset telling you what would be the best storage type that you can choose upon the metrics that we are getting from your disk usage.
So you mentioned asking Q there. That's quite a nice segue into the other blog post that we were hoping to discuss today, which is a post that you wrote on the AWS Cloud Financial Management blog, all about introducing AWS pricing capabilities in Amazon Q Developer. Ask questions, get instant cost insights. So, what kind of questions can we ask Q, and what kind of insights might we get from asking Q about costs?
Oh, you come back, John.
Briefly, never even aware. Did you know you'd disappeared?
Yes, it said reconnecting, and then it just jumped back in again.
The internet is just for the last month or so. The internet stability has been questionable, shall we say? Anyway, that's not what we're here to.
Undersea
Yeah,
cables.
we can.
It's
This
not what
is
we're here
the
to talk about. So.
So yeah, I would say there is I would say with the agentic AI, MCP, and sometimes we are not taking care of getting the right data source and to provide accurate information. And this is true that when I'm speaking with customer, one of the AI adoption issue, even this is not anymore, there is no more adoption issue with AI, but I mean, one of the problem that the user are always saying is we have hallucination. And that's why it was important for us, if we are providing a tool, having the ability to, I would say, not replace, but give you the ability to, instead of using the pricing calculator manually, to speak in natural language and to get the data very quickly. And being able to get, for instance, you have multiple region in Europe. You need to launch a new application, and you don't know where to settle this region. I would say this application in which region, because you don't know first is all the instances are everywhere, and where the price will be the best, because you don't care about the latency. It's really internal, or there is no latency dependency. So you want to find the region where you will have this instance type or all the service that need to be, I would say, deployed for this application at the best price. So you can just, okay, I want to deploy a web server with a RDS Postgres database. and to serve, I don't know, 1,000 connection per day, 10 hours per day. And it will tell you what will be the best architecture in which regions in EMEA, where you will have the exactly the right pricing, the best pricing, and you can even compare to to ask him to compare to the other region to tell you the difference. Recently, I also have a use case, and I use this tool. It was for a customer. We were looking what will be the best regions to implement this BCP. So BCP is backup continue plan, or DRP, I would say. And he has a list of service that he would like to be sure to have in Asia region. So we just list the service to queue, and we ask, okay, which region have all these service implemented yet? And you get directly. So if you have to do the same in the pricing calculator to search each region by region, it will be complex. So here you can get very accurate information, and on top of it, of course, so you have the pricing API, the documentation, the AI that will guide you across. So an architect can now, I would say, going faster to provide a pricing estimation to the business when you need to do it, I would say.
Yeah, there are some examples in the blog post. So, prompts that you could give to Q and the sorts of answers you can expect. One here about running a batch job, processing 500 gig of data daily using Lambda versus Fargate. So what's going to be more cost effective? Is it Lambda or Fargate? There's another one just about instant sizing. I need 2 CPUs, 16 gig of memory for intense workload in EMEA. Open to Graviton. What's the best pricing option? So these are examples of the kind of things that you could be asking Q for. John, have you ever tried this?
I've not done it with Q. I've certainly used other. Maybe I have done it with Q. I don't know. I've certainly used LLMs to just quickly estimate a price for me because I couldn't be bothered to go and work it out. Because genuinely, getting that data out historically has been really hard, to the extent that, okay, you can go and look it up from the various different service pages. You can go and look it up from third-party things, particularly for like EC2 instance sizes and what have you. But the ability to just say, I have this architecture, tell me what it's going to cost, please, and then, assume some sort of traffic throughput or give it some traffic throughput. It's generally been quite good. I should have to try Q instead of sort of the GPT models, but they're just more convenient, I think, because I don't have to log into a console to do it.
No, I think the main issue with the LLM is the pricing, because you do not have the accurate pricing. The LLM are not refreshed every day, or you might not have accurate. That usually the problem with the LLM. You never know. If they don't know, they will not say, I don't
They're
know.
constantly wrong.
They will tell you something. Here you are directly connected to the API of the service with the real pricing. So you are sure that you are getting accurate information and the latest pricing information. Even because AWS is decreasing the price quite often, so it's very important to get the latest pricing.
Yeah, I mean, if you look at ChatGPT and what have you, I call it an LLM, but these days the chat interface is agentic, because you can say go off and Google it and whatever, and it's generally quite good. But yeah, you're not wrong, because it's horse's mouth, so to speak.
Yeah.
And
so
is it?
Yes. Sorry.
So I was going to ask a question. Is it intelligent enough to point at an existing workload? So could you ask Q to say, hey, this workload that I've got running in this AWS account, what would it cost to run that in another region? Or would you need to be more descriptive in terms of your prompt?
So that was already existing before these features, because we already, I don't remember exactly. Yeah, I remember now. It was during the FinOps 6, so June 2025. We launched Q inside Cost Optimization Hub. So you had already this ability of cost optimization inside Q to tell him, look this my storage, or tell me what are the best option to optimize my compute. And also so this is not yet down, but I discussed with Liam. Uh, I have not the roadmap in mind, but you have this pricing calculator in the console where you can, I would say, use the workload that you have and the discount and the commitment that you have to project. So one of the next step for Q and the pricing calculator will be to integrate the pricing calculator in the console to Q in order to replicate the same with existing workloads. So
Yeah,
this
we've
is
definitely.
yeah. I
Yeah,
don't have a specific date for the roadmap, but this is actually in progress.
Yeah, we've used the pricing calculator inside the console. It's pretty good, actually, being able to import existing workloads in. I think without using Q, though, you probably need to go through and change every line item for the
Yeah.
region on every individual service line item to get the answer, which could be quite tedious. And it's absolutely the sort of thing that AI could automate and speed up for you. So
Reinvent is in 2 weeks, so stay tuned. And yeah, there is interesting session about the pricing calculator in the console. About Liam will do also interesting presentation about Q interaction with API. So I even don't know if what will be released, because even internally this is not something that we know. That's why it's super important to, I would say, this week. The only thing I can tell you is this week, in terms of FinOps, we will have some release, but I don't know which ones. But I got the information that some news are coming out this week.
Well, we'll keep an eye on that because, as we know, this is an AWS News podcast. So hopefully we'll pick up on any new exciting FinOps announcements and discuss them in future episodes. Yeah, I mean, we noticed last year, actually, there was definitely not a news drought ahead of reInvent. There was so many things being released before reInvent. You're thinking, how on earth are they going to have anything left for reInvent? I guess the pace of innovation is just so crazy that there's always stuff to talk about. So
yeah, I think we'll have a lot.
Oh, we lost Loic due to maybe Cloudflare. Who knows? Perhaps he'll come back. No, he has come back. There we go.
Yeah. So, who's the next one?
I think we better quit while we're ahead, lads.
Well, we are, we are approaching the end of our time for this week's episode. So I don't know if, John, if you had any further questions for Loic while we have him, or if this is a good opportunity for us to wrap up the episode before Restream does that for us.
No, I think we need to end.
Cool. Further technical problems. Who knows who's to blame this week, but we have managed to reach the end of season 4, episode 43 of Logicast, with all three of us still on the stream. So thank you, Internet, for smiling down on us and allowing us to finish the episode. That really is all we have time for season 4, episode 43 of Logicast. Just remains for me to thank you, John, for your insights, and thank you to our guest this week, Loic Fournier, Senior Technical Account Manager at AWS, for sharing your insights around cloud financial management and dangling that carrot for us of some exciting FinOps announcements over the coming weeks and at reInvent. So we'll certainly be keeping our eyes peeled for those and hopefully discussing them in a future episode of Logicast. But that is the end of season 4, episode 43. Thank you very much for listening. If you've enjoyed it, please give us a review. Tell your friends. We are available to download from wherever you download your podcasts. If you'd like to see us all disappearing and reappearing just like magic, check out our video feed on our YouTube channel, the @Logicarta YouTube channel. We will be back, internet permitting, with another episode for you next week. In the meantime, thanks for listening, and we'll see you again next time.